There are three basic design configurations for a distribution system. There's the arterial loop system, the grid system, and the tree system. An arterial loop system is a distribution system with a complete loop of arterial mains around the area being served to minimize dead ends. Features of an arterial loop system include large diameter mains around the service area. Water is supplied from 4 directions, which means if you were to have a fire hydrant at an intersection and open that fire hydrant up, water would be coming from 4 different directions to supply that hydrant. And it has good flow throughout the system. The next type of system is the grid system. A grid system is a distribution system layout in which all ends of the mains are connected to eliminate dead ends. And some features of the grid system include most of the water mains are interconnected, the mains are reinforced with larger arterial mains, and flow is usually good if the mains are 6 inches or more, and you'll draw flow from 2 to 3 directions. And the third type of system is the tree system. A tree system is a distribution system that centers around a single arterial main, and branches are taken off at right angles, and they have dead ends. So the transmission line delivers water into an area. The distribution main branches are not interconnected, and this results in dead ends, which ultimately results in poor water quality. Dead-end mains that are longer than 1,000 feet should be at least 6 inches in diameter. Isolation valves are required to allow for system isolation for maintenance or repairs. These valves should be spaced periodically so that small sections of the system can be isolated if there is a problem requiring a shutdown lasting more than a few hours. Water mains less than or equal to 12 inches in diameter should have isolation valves within 1,000 feet of each other. All branches off the arterial mains should have isolation valves as well. In situations where mains intersect in a grid, at least 2, but preferably 3 isolation valves should be installed. Air relief valves should be installed at the system high points to release air that's come out of solution, since this can reduce system flow. Backflow prevention devices should be installed to isolate the system from potential contamination sources. The carrying capacity of a water main is determined by its size. Water mains must be sized to meet peak demands from domestic, commercial, industrial, and fire protection uses. They must be able to deliver adequate quality, quantity, pressure, and velocity. One of the primary goals of distribution system operators is to maintain good water quality throughout the entire distribution system. The design of the system impacts the operation and maintenance procedures required to maintain good water quality. Arterial loop systems are preferred to grid systems, which are preferred to tree systems. Domestic use requirements can be determined by either referring to past usage records or from general usage figures for the area. Fire flow requirements are usually the determining factor for system size in communities with a population of 50,000 or less. Fire flow requirements are set by the Insurance Services Office, or the ISO. Fire insurance underwriters recommend that no main in the distribution system should be less than 6 inches in diameter. They also suggest the following minimum requirements. High-value districts, such as libraries, shopping centers, and the like, should have 8-inch mains and larger. Residential mains of 6 inches or larger, and mains smaller than 6 inches are only used to complete a grid. 35 psi at all fire hydrants is the minimum pressure able to meet fire flow requirements in areas requiring high fire flow capacity. The system should be able to ensure the pressure does not drop below 20 psi while used during firefighting operations. Residential pressure is typically kept in the 50 to 75 psi range, while commercial district pressure is in the 75 to 100 psi range. Systems that serve a community that has different elevations within it will find it necessary to have different pressure zones. Although customers want good water pressure when they turn on the faucet, excessive pressure can damage fixtures and water appliances. High water pressure will also contribute to more leaks in the distribution system. Flow velocity should be limited to 5 feet per second in the distribution system to avoid friction losses during normal operations. Water velocities are reduced by increasing the diameter of the pipe for a given volume of flow. Systems are typically designed to provide a flow velocity of between 2 feet per second and 4 feet per second during maximum flows.